Imagine waking up one day and realizing that humanity may have already taken the last close-up photographs of Pluto that we will ever see in our lifetimes. Not because the technology doesn't exist, not because we lost interest, but simply because nature, physics, timing, and the limits of our engineering have combined to shut the window almost completely. This idea sounds unbelievable, but the truth is even stranger. The best images of Pluto we possess were captured during a single flyby that lasted mere hours, and the spacecraft that took them is already millions of kilometers away, heading into interstellar space with no way to return. There is something uniquely unsettling about this. We live in an age where it feels like nothing is out of reach. Telescopes can peer into distant galaxies, rovers drive across Mars, probes land on comets. Yet Pluto, once the ninth planet, now a distant dwarf world, remains almost completely unvisited, photographed up close exactly once. And here is the twist. There is no active plan, no approved mission, and no realistic timeline for going back. Scientists have proposed follow-up missions, yes. Orbital concepts, atmosphere samplers, even landers that could touch down on its nitrogen ice plains. But these remain ideas on paper, not projects in progress. The biggest problem is distance. New Horizons, the only spacecraft ever to reach Pluto, took almost a decade of perfect travel to get there, and it did so without stopping. It simply shot past at incredible speed, snapping everything it could in a few fleeting moments. To slow down enough to enter orbit around Pluto would require an amount of fuel no modern rocket can carry. And even if we solve the propulsion problem, there's another challenge: timing. Launch windows to Pluto are rare, opening only once every couple of decades. Miss one, and you wait years for another. By the time a new mission is approved, built, launched, and finally arrives, entire generations will have passed. That's why scientists say the images from 2015 may stay unmatched for the rest of the century. The icy mountains, the flowing nitrogen glaciers, the stunning heart-shaped region known as Tombaugh Regio, these may remain frozen not just on Pluto, but in our archives forever.
But why is returning so difficult, especially when we've sent orbiters to worlds much farther away, like Jupiter and Saturn? The answer lies in orbital mechanics. Pluto is not only distant, it is moving fast relative to Earth, and its orbit is highly elliptical. New Horizons reached Pluto by accelerating to enormous speeds, riding a gravity boost from Jupiter. Those speeds made a flyby possible, but made stopping impossible. If we want to orbit Pluto, we must cancel nearly all that velocity upon arrival, which means carrying an enormous fuel supply or inventing a new propulsion system entirely. Neither option exists today. Even if engineers could somehow build a spacecraft capable of slowing down, we still face the problem of power. Pluto lies far beyond the reach of solar panels, so any mission would need nuclear power sources that are currently limited and difficult to approve. Meanwhile, Pluto itself is changing. When New Horizons flew past, Pluto was moving away from the Sun, and its thin atmosphere, made mostly of nitrogen, was beginning to collapse and freeze onto the surface. Scientists desperately want to see those changes up close, but unless a future mission coincides with Pluto's orbital position in just the right era, we might never observe the transformation directly. This is why the New Horizons images are so extraordinary. They show a world that was, in that moment, uniquely active. Hazy blue skies, sunlight scattering off suspended particles, glacier-like flows across vast plains, towering mountains made of water ice harder than granite. They capture Pluto at a time when its atmosphere still lifted into space, forming multiple layers of delicate, luminous haze. But that version of Pluto, dynamic, atmospheric, alive with seasonal change, may now be gone, and our only evidence of that era comes from those single pass-by images. This creates a strange scientific paradox. We have just enough data to know how much we are missing. The more we learn, the more unanswered questions appear. How often do Pluto's glaciers shift? Does the heart-shaped region drive global weather patterns? Are there cryovolcanoes hidden beneath the frozen plains? New Horizons gave us hints, not answers. And without a return mission, those mysteries may remain untouched for centuries.
To make matters even more complicated, Pluto isn't the only world we may never visit again. After its historic flyby, New Horizons continued into the Kuiper Belt, targeting an object called Arrokoth, one of the most pristine relics of the early solar system. Its surface is unaltered by heat, radiation, or geological change. It is literally a time capsule from the era of planetary formation. But just like Pluto, Arrokoth was photographed once during a single rapid encounter. The probe could not slow down, it could not circle back, it could not take more images later. Every detail we have, the twin lobes, the smooth connection between them, the subtle color gradients, the shallow depressions, comes from that one moment in 2019. And now Arrokoth is shrinking behind us, just another faint object in the growing distance. So why can't we simply send another spacecraft? Because the Kuiper Belt is vast beyond imagination. Objects in it are faint, small, and incredibly hard to target. Even New Horizons required years of searching to find Arrokoth after the Pluto flyby, and that was with the probe already in the Kuiper Belt. Hitting such a target from Earth decades in advance would be like throwing a dart across a football field and hoping it lands on a grain of sand. Our technology can do it, but only with extreme luck, precision, and alignment. And there is another challenge: time. New Horizons' triumph worked because the mission began in the 1990s, when funding cycles were favorable, plutonium for power sources was still available, and the spacecraft could launch during a rare alignment window. Replicating those circumstances today is nearly impossible. Even if a new mission were approved tomorrow, it would take years of development, years of travel, and years of navigation before reaching Pluto or any Kuiper Belt object. That's why many scientists quietly acknowledge that New Horizons might remain the only mission of its kind in our lifetimes. The spacecraft itself is also running out of energy. Its power source decays each year. Instruments will have to shut down one by one. Eventually, even its transmitter will fall silent. When that happens, the final images of Pluto and Arrokoth will not just be historic, they will be all that humanity has.
So what does that mean for the future? In a way, it forces us to rethink how fragile moments of exploration truly are. The images from New Horizons are not just scientific data. They are snapshots of worlds we may not visit again for a century or more. They represent the limit of what one mission could achieve while racing through the frozen outskirts of the solar system. And now, as the spacecraft drifts further away, the reality becomes clearer. If humanity wants to see Pluto again up close, we must develop propulsion systems far beyond what we have today. Nuclear electric propulsion, fusion-based engines, or beamed sails might one day make an orbital mission possible. But until that happens, Pluto remains a world we glimpsed only briefly. And that fleeting glimpse, ironically, revealed how much more there is to learn. The strange nitrogen frost patterns, the possibility of hidden subsurface layers, the behavior of its collapsing atmosphere. None of these can be answered from Earth. We need to be there. We need another spacecraft in orbit. But we may not get one in our lifetimes. And that is why the phrase, "the final images we may ever see," is not an exaggeration. It's a warning and a reminder. Exploration is not guaranteed. It's not infinite. It depends on physics, funding, timing, and willpower aligning perfectly. And sometimes we get only one chance. New Horizons used that chance flawlessly. It gave us landscapes that feel almost impossible, towering ice mountains where the sunlight bends through thin haze, smooth plains that behave like glacier fields, ancient surfaces preserved for billions of years. It showed us a world that was more complex than anyone predicted, but it also showed us the limits of our reach. Unless something changes, unless humanity pushes farther and faster, the next time Pluto comes into the right orbital position for a return mission, none of us will be alive to see it. And so we hold on to the images we have, clear, detailed, irreplaceable. They're not just photographs. They are the record of a moment that will not repeat. A moment when human engineering touched the edge of the solar system and captured a world that, for now, will remain forever out of reach.